Welcome to In Depth with Academia, where we take a close, thoughtful, sometimes meandering look at cutting-edge research. I'm Richard Price, CEO of academia.edu, and as always, I'm here to walk you through new work from the academic community, helping you to reflect on what it might mean for, you guessed it, your own curiosity, or maybe just your next conversation with a science-minded friend. So let's get started. And as a little reminder, my job here is to present the research neutrally. This isn't an endorsement, it's an exploration together today. We've got a fascinating paper authored by Danny Iwanto. It's titled Deglacial Rapid Inundation and Land Loss of Sundaland. A mouthful, right? But trust me, the implications are big. We're talking about a region that once connected mainland Southeast Asia with the islands of Sumatra, Java, Borneo, all the land that is now beneath the shallow seas of the tropics. So what's the central question? What is this paper really wrestling with? Well, it's all about how much, how fast, and exactly where Sundaland lost land as the planet came out of the last ice age. How did this massive land bridge, bustling with prehistoric rivers, forests, maybe even early humans, how did it end up underwater? Why does it matter? It matters because those changes set the stage for everything from modern island biodiversity to human migration routes. Think about that. Places where your ancestors might have walked, now under the Java Sea. So let's get to the tangible stuff, the methods and results. Iwanto used two main data sets here. The first is a very high-resolution seafloor map, the GEBCO 2025 bathymetric grid. Bathymetry is just a fancy word for mapping underwater terrain. The second thing is a timeline, specifically a curve, showing how sea level rose in the region over the past, say, 2,500 years. That's back to the last glacial maximum, when the world was a lot icier. These two sources were combined, map plus timeline, so the researcher could reconstruct step by step how the coastline retreated and land got submerged. Iwanto calculated the shrinking land area every step of the way. It turns out, and wow, brace yourself, Sundaland lost about 2.5 million square kilometres of land since that glacial peak. That's like an area nearly the size of modern-day Greenland. And at its most dramatic, during these events called meltwater pulses, the peak rates of land loss hit more than 1,260 square kilometres per year. Imagine whole cities or counties just gone underwater in a flash of geological time. But the really neat insight is that the flooding wasn't the same everywhere. Western Sundaland, like the shallower Sumatra Shelf, got gradually nibbled by the sea, but the Java Sea and the Karimata Strait and the corridor into the South China Sea, these places saw sudden, almost catastrophic land loss as water spilled over geological sills, drowning enormous areas quickly. So, local topography mattered a lot. If you picture a series of shallow bowls getting tipped and suddenly filled, that's kind of what happened. Okay, here's a quick digression. Did you ever notice how maps of Southeast Asia kind of look like a jigsaw puzzle that's missing a few pieces? Well, you can almost imagine people thousands of years ago walking huge distances and then one day finding their shortcut underwater and just standing there wondering, what happened? We'll never really know those stories, but wow, it's fun to imagine, isn't it? All right, focusing back on the findings. Iwanto notes that these changes didn't just shift coastlines. They broke up huge ecosystems, turning forests into little island sanctuaries, even shaping the way animals and plants evolved. For humans, it meant their homes, hunting grounds, and migration routes got squeezed or wiped out. There's evidence, in fact, that these changes corresponded with new tools, new ways of living, and maybe even stories of lost lands that echo in ancient myths. That's pretty wild. Of course, the study has its limits. It's based on bathymetry and sea level curves, but doesn't factor in stuff like tectonics, sedimentation, or river movements. So it gives us a first-cut quantitative look, but not the absolute final say. That's a super important reminder. Academic research is always provisional and offers one set of insights among many, not the ultimate blueprint of the past. So, why should you care, really? Well, besides imagining ancient landscapes, it's a powerful reminder that the world we live in, the places we call home, our coastlines, our migration stories, all these things are built on changes, often sudden ones. Understanding those changes helps us reflect on today's environmental shifts too. The world's coastline is always in motion, and that can be both scary and kind of inspiring. As always, thanks for tuning in to In Depth with Academia. Remember, all research is a window, a tool for reflection, not a rule book. Keep asking questions, keep exploring, and who knows, the next lost continent might be hiding just beneath the surface of a story you haven't heard yet. Until next time, this is Richard Price, presenting, not endorsing, signing off.